In this presentation, we're going to look at experimental design in psychology, which basically is how you allocate participants to your different experimental conditions. So let's have a bit of a recap first of all to see what you remember. So you'll remember every experiment has an IV and a DV. And in basic terms, the IV is the variable which you manipulate or change in your two conditions, and the DV, the dependent variable, is the variable that you measure. So the IV is the cause and the DV is the effect. We always have an alternate hypothesis. That basically is our prediction. Remember, the important thing is to operationalize your variables, which simply means to state them in clearly measurable forms. We also have to have a null hypothesis, the hypothesis that says that there was no effect of the IV on the DV, and any effect there was just due to chance. And our hypotheses can be directional or non-directional. Remember the rule: if there's been previous research that suggests the direction of change, then you can use a directional hypothesis or a one-tailed hypothesis. If there's been no previous research, then you must use a non-directional or two-tailed hypothesis. So in most simple experiments, we usually have two conditions, and we usually refer to them as condition A and condition B. One of them is the experimental condition. This is where you manipulate a variable, the IV, to see the effect on the DV. The other condition is B, condition B, the control condition, and that's where nothing is manipulated so that we have a baseline to compare our results with. So let's think of a simple experiment and look at the conditions. So an experimenter wants to see if drug X improves sport performance. One group are given the drug, another are given a placebo, and both groups are tested for athletic ability. One thing that you should note at this time is that not all experiments will have a control condition. For example, if your independent variable was gender and you were testing for a difference between men and women, then your two conditions would be men and women. So in our example above, obviously the independent variable, the IV, is the drug, and the dependent variable is the score on the test for athletic ability. So our two conditions, our experimental condition is the participants who are given drug X, and our control condition is the group that are given a placebo. And a placebo, by the way, is a fake drug, one that doesn't have any effect. So what do we mean by experimental design? It's all about how we allocate our participants to those conditions. And there are three main ways that participants can be allocated to conditions: independent measures design, repeated measures design, and matched pairs. So let's have a look at repeated measures first of all. Now, as the name suggests, that means that participants are doing two things. So they're doing both conditions. So every participant takes part in both the control and the experimental condition. So to give you an example, if we wanted to test the effect of alcohol on reaction times, participants would have their reactions times measured first of all, and then they'd have an alcoholic drink, and then they'd have their reaction times measured again. So our control condition is measuring the reaction times before, and our experimental condition is measuring the reaction times afterwards. So you can see we've got exactly the same people in each condition. Now, one of the good things about this is we haven't got any participant variables or individual differences to act as confounding variables on our experimental results. We also need fewer participants because we're using the same people in both conditions. There are some problems though. There's more of a risk of demand characteristics, so participants are much more likely to work out what you're trying to find out and change their behaviour accordingly. And there's risk of order effects. So people might get better because they've practiced, because they've done it before, or they might get worse just because they're bored or tired. So that brings us on to independent measures design. In this design, each participant is only used in one condition, so either the experimental condition or the control condition. If the IV is gender or age, then independent measures design is the only possible design we can use. So in our example, one group would have their reaction times tested without having any alcohol, and the other group would have their reaction times measured after they'd had a drink. So you can see that they're completely different people. Our strengths and weaknesses flip over from repeated measures. Our strength is we've got a lower risk of demand characteristics because participants are only doing something once. We haven't got an issue with order effects, so there's no boredom or fatigue or practice. The weaknesses though, obviously there's a much higher risk of participant variables or individual differences playing a part. In this example, people's tolerance to alcohol could be a confounding variable. And we need twice as many participants as a repeated measures design. Our last one that we're going to look at is a matched pairs design. So it's similar to repeated measures, but the participants are matched with each other. So the two groups are as similar as possible. Now what you match them on depends on what you're testing them on. One way to think about this is to imagine, you had access to identical twins and you could put one twin in one condition and the other twin in the other. So on this example, the experimenter selects two groups of participants and then matches them. And for our little example on alcohol, things that might affect tolerance to alcohol would be age, gender, weight, and usual alcohol consumption. So once we'd match people, one half of the pair goes into condition A and the other half goes into condition B. So they are similar but not the same. So our strengths then, participants' variables are reduced. They're not completely got rid of though, because the people are different. They're similar but they're not exactly the same. There's no practice and order effects, and there's less risk of demand characteristics. The problem though is that participants can never be completely matched, even identical twins. The older they get, the less identical they become. And of course, it's very time consuming and expensive to accurately match people. And we need a lot of participants because we've got to try and match them all. That means we've got to reject people, find more people, etc. So let's have a look now at a little activity to make sure you've understood this. So we've got 6 scenarios here. A study to see if there's a difference in the ability of grey and white rats in learning to run a maze. A study to investigate whether a twin born first is more confident than a second born twin. A study to see if watching violent TV programmes is likely to make children aggressive. A study to investigate whether people are more likely to make a risky decision when they are in a group than when they are alone. Research into finding a cure for fear of spiders, comparing a treatment group with a non-treatment group. And finally, an investigation into whether people prefer gin and tonic or vodka and lime. So pause the video now while you have a go at these and work out what experimental design would be best for these studies. Okay, so pause now. Okay, so if we have a look at the answers to these questions. So the first one, it would be an independent measures design because the colour of the rat was the IV. The second one would be matched pairs because they were twins. The third one would be a repeated measures design because we're measuring aggression before and after the TV programmes. The fourth one would be an independent measures design to control for demand characteristics. The fifth one would be independent again because we've got a treatment and a non-treatment group. And the final one would be repeated. They'd try both the gin and the vodka. Okay, I hope you found that useful. What I would suggest you do now is read the relevant pages in your textbooks on experimental design and look at some past paper questions to see what sort of questions you could be asked on experimental design. Thank you for listening.